Okay, the new problems today look like this, and most of us, if we just look at that, it looks similar, right? Couple differences. First obvious difference is this is two things on top of one. That's a pretty obvious difference. The second, maybe less obvious difference is the fact there's letters in the denominator. That makes it a different kind of problem. Okay? The slight difference to this is that we have to make a list of numbers that are not allowed to be the right answer to this problem. Okay, where usually we just work the problem out, we get what we get, and we're done. When you start getting letters in the denominator, there's going to be a list of numbers that are not allowed to be the right answer. All right, and I'm going to put t equals, and I'm going to slash the equals because it's not equal to. And I'm going to compile this list of numbers. All right, and I say numbers, it could be number, but we have to ask ourselves a simple question. What values of t will make the denominators equal to 0? Anything that does that has to be thrown out as a possible answer. So, if there's just a single letter on the bottom, like t, if t equals 0, we're dividing by 0. If a t or whatever letter you're dealing with is being multiplied by a number and there's no pluses and minuses happening, that's also 0. If t is 0, 3 times 0 is 0, we have division by 0. Bless you. All right. We know from earlier in the year that division by 0 is illegal in algebra, right? Can't do it. So any value of t that creates 0 in the denominator would be bad. This is my not allowed list. Okay? All that list does for me is this. I'm going to go about and solve the problem just like I did a moment ago. But at the end, if it says t equals 0, I have to throw the answer out. If it says t equals anything else, I'm good to go. All right, so step 1, when letters in the denominator, make a list of things that aren't allowed. Then work the problem out. Now, this problem has a similar structure to the last one, the fact we have fractions in it. The fractions have denominators of t,
And
3t, and 3. What's the least common denominator of those?
3t.
3t, very good. The factors are 3 and t, both to the first power is the highest power. So the least common denominator of these fractions is 3t. And just like before, I recommend getting rid of fractions. In the process of doing this one step, that's what allows sometimes this answer, if it happens to be the answer, to show up as an answer. Okay, if we didn't do that, this wouldn't be necessary. But again, it makes it so much easier to not have the fractions in it. It's worth doing. So now when I multiply this times this, notice 3t divided by t makes what?
3.
3. That's got to multiply by the top, which is t minus 2. Since the top is a binomial, that quotient, 3t divided by t is equal to 3, has to multiply not just by t, but also by minus 2. When I do this times this, equals, of course, right?
14.
3t divided by 3t is 1 times 14 is 14. When I do this times this, it's going to be minus because opposite signs. 3t divided by 3 is t times 1 is t. So once again, by multiplying by the least common denominator 3t, I've successfully gotten rid of all fractions. This equation has the same exact answer as the top equation, with the one extra feature that 0 could possibly be an answer to this, where 0 is not allowed to be an answer to the top one. If this was the problem to start off with, 0 would be fine as an answer on this one. But on this top one, 0 is not legal. So, if I go ahead and solve this distributive property first to simplify, I'm going to get 3t minus 6 is equal to 14 minus t. I'm going to move the t to the left, so it's going to be plus t on the left. Move the 6 to the right, it's going to become plus 6 on the right. 3t plus 1t makes 4t. 14 plus 6 makes 20. Divided by both sides by 4, then t is equal to 5. What's t not allowed to equal?
0.
0. Is 5 0?
No.
So all's well. It happens occasionally. Not often enough that you have to be super concerned about it, but it happens often enough that if you want to get everything right all the time, you'll miss some occasionally if you don't do this. Okay. More often than not, this is necessary to be done, but then you get down to the bottom and it doesn't happen. So that's more common